Hey, welcome back, students. In this video, I want to go ahead and talk to you about predicting the products of a chemical reaction. And so you would have gotten some problems from me already in terms of the recent activity on this. And what I want to do is just do a couple of problems for you in this particular video, and maybe if we need to, we'll do some more. Let's go ahead and I'm going to go ahead and do number one for you. This is pretty easy. So let me go ahead and write the equation down for you, and then we'll go from there. So in number one, what you had here, let me just go ahead and do this. Number one, you had HCl, and it was being added to, let me go back actually, it was being added to magnesium, and you were being asked to determine what does this form. And so one of the things that you do need to remember here is you must take into account the activity series. This is very important because with the activity series, this is what allows us to determine whether a reaction is going to occur or not based on the activity series or the strength value of a particular compound. And so what we got to do is we got to compare here the cations. And so activity series entirely deals with here the cations. So let me put here, look at the cations. Okay, and so in this particular case, the two cations are hydrogen and magnesium. So that's really the question we're asking. We're asking, is hydrogen greater or less than the activity series when compared to magnesium? And so in this particular case, what you're going to find is that magnesium actually is the bigger of the two. Magnesium has a higher activity series than hydrogen. And so what that means is that the reaction here will proceed with magnesium coming in and displacing the hydrogen so that it binds with the chlorine. Now, with all these types of problems, what I would like you to do is go ahead and do this with respect to the steps that I've shown you in class. And so the actual steps that we use is whenever you've got a compound, go ahead and split it. The first atom is going to be the positive one. In this particular case, the atom actually winds up being a positive atom, and so that'll be a +1 charge here, and then the chlorine is a -1 charge. Now magnesium on its own, because it is a solid, typically will be a 0 charge, but when it actually loses the electrons that it has in the valence shell, magnesium becomes a positive atom, and so the actual charge for magnesium here will eventually become a +2. So what will happen here is that the magnesium will come in here and displace the hydrogen. It'll actually bump it out. And so given that that's what's going to happen, let's go ahead and make the prediction over here on the right side. And so what you'll get here is going to be magnesium bound to chlorine followed by hydrogen. Now do remember that hydrogen is a member of the Super7. And so the Super7, just to remind you here, let me write this down at the bottom here. The Super7 elements are going to be hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And the reason we call them the Super7, because if you look at the periodic table, the number that they form when you look at if you connect the dot between all of these elements here, with the exception of hydrogen, these elements over here at the bottom, these actually form a 7. And so you'll have nitrogen, oxygen, fluorine, and then on the way down, chlorine, bromine, and then iodine. So if you look at this structure here, that's actually the number 7. And so that's actually what's going on here with these Super7s. But the thing about the Super7s here is that they do not like to exist by themselves. They exist as diatomics. Okay? And what that means for you is that whenever you see them, they actually want to form a diatomic, because what they want to do is they want to get that lower orbital, the 1s orbital, they want to fill it out. And the only way that that's actually going to happen is if they get another partner here, if they get actually this another member of its group coming in and combining with it there to form an actual diatomic molecule. So this here is the diatomic molecule. And what will wind up happening is that they themselves will then become stable. And that's really what it does. It does not want to be a lone one valence electron atom monatomic. It actually wants to be the diatomic, because here this particular one becomes H2. That is actually stable. And so just keep that in mind. And when you see hydrogen or any of these other Super 7 elements formed on the other side of a reaction at the product, make sure you put the subscript of 2. Okay. Now you also know that hydrogen here is going to be a gas. So let's just take this and identify it as gas with a little g. Now the next thing we need to do is transfer the charges that we had in the reactant side. Magnesium is a +2, chlorine is a -1. And so what we'll see here is that the charges +2 and a -1, these do not give us a neutral reaction. So what we'll need to do is actually engage a crisscross mechanism here to give us the overall charge. And so we'll bring this 2 down here and write it down there. And so let me just clean it up and actually put it there. Now the reaction is overall balanced. And so here, or at least it's neutral, not balanced. That's the next step that we need to do here. Is once we've made the prediction and every compound in the product side is neutral now by charge, the last step for us is to actually go through and balance things out. And so that's what I'm going to go ahead and do now, because we need to make sure that we do that. And so begin with the first atom, hydrogen. We've only got 1 on the left. Look over here on the right, we've got 2. So in order to solve that, what I'm going to need to do here right off the bat is I'm actually going to need to make another copy of HCl. I'll go ahead and fix the numbers here at the very end, but for right now, let me just write the copy. So now we've got 2 copies of hydrogen, 2 copies of hydrogen on the right, and we have 2 copies of chlorine and 2 copies of chlorine, and then followed by 1 copy of magnesium in the reactants, 1 copy in the product side. So we are actually done here. So go ahead and count all the copies of the compounds. Here you notice that you've got 1 copy, 2 copies, so the coefficient here is going to be a 2. There's only 1 copy of magnesium, so that coefficient is a 1. 1 copy of magnesium chloride, so that copy, or the coefficient is 1. There's 1 copy of the hydrogen, so that copy is 1 as well. The only thing that I have not done that I should have done a little bit earlier is make sure that you identify the actual proper solubility of magnesium chloride. And if you go look on magnesium chloride in the actual solubility table, what you notice is that magnesium chloride is actually AQ, aqueous. Now, aqueous here is because when you look at the solubility table, it's going to wind up being SOL. So when you see the SOL, you're going to have to put AQ instead of SOL. Now, you don't put SOL whenever you see insoluble. Whenever you see those, you actually want to put solid. But this is the way you actually make a prediction of the products. And you have to use charges. You do have to use the activity series. And then at the very end, you definitely have to use the solubility table so that you can figure out whether it's aqueous or not. Keep in mind that SOL is equal to AQ. And INSOL is going to be equal to the solid. So it'll be equal to the solid. So that's essentially all for this activity. I'll go ahead and make some more here in a little bit for you. But if you have any questions, see me obviously during tutorial. But keep watching, keep learning, and we'll see you in the next video.